Hi guys, so this is part 3 of my diabetes videos. In the last couple of videos I talked about the history and how diabetes comes around and the risk factors that we have for diabetes. So today I'm going to talk about specific foods that affect our blood sugar, and there's different foods that affect our blood sugar, but today I want to concentrate on you and your carbohydrates. So just to recap, we talked about how the food that we eat can affect our blood sugar, which affects our pancreas and releasing insulin. And if we have too high blood sugar and too much insulin being produced over a long period of time, then we end up with diabetes. So today I want to focus on how carbohydrates affect our blood sugar and how we can use that to control our blood sugar and hopefully prevent diabetes. So carbohydrates, what are they? So when we're talking about the chemical aspect of carbohydrates, they're made up of carbon, hydrogen and oxygen. Another word for carbohydrates is saccharides, and this is a Greek word for sugar. So when you hear carbohydrates, sugar, saccharides, it means the same thing. So carbohydrates are divided into 4 groups, and these 4 groups have to do with the number of sugars there are. So we start from the most simple and the most basic sugar, and that's called monosaccharide. So mono means one, saccharide means sugar, so that's just one sugar. Chemically, that means you just have one unit of sugar. This cannot be broken down into anything else. Three monosaccharides. There is glucose, there's fructose, and there's galactose. Glucose is found in lots of processed foods, things like chocolates and cakes, and lots of processed juices and drinks. But it can also be found in natural things like honey. Fructose is a type of sugar that's found mainly in fruits. And galactose is a type of sugar that's found in lots of different types of dairy products. So the next saccharides is disaccharides. So di means 2, saccharides means sugar. So this is 2 units of sugar. So this might be 2 glucose together, 2 fructose together, or maybe a glucose and a fructose, but it's just a combination of the monosaccharides. And the most common disaccharide is sucrose. So this is your common table sugar. It's also found in certain things like carrots and sugarcane as well. Another disaccharide is lactose. So this is in dairy products. So this is the sugar that people can be intolerant to. So if you're lactose intolerant, it means you can't digest and you can't process this sugar in your intestine. And I did a video about fats, and basically that talked about how something like lactose ends up in your large intestine, and your bacteria take up this sugar and they produce lots of gases and lots of different things that leave you feeling bloated and uncomfortable. So the next group of saccharides are called oligosaccharides. So this is chains of 3 to 10. So again, you just get a combination of the monosaccharides and the disaccharides, and if you have 3 to 10 of those, that's called an oligosaccharide. So there's a long list of different types of oligosaccharides, and it's found in lots of different types of foods. It's found in wheat and cereals. It's also found in lots of fruits and lots of vegetables. They're also found in legumes and lots of nuts. So now when you end up with having more than 10 of these units together, that's called a polysaccharide. So poly means many, saccharide means sugar. The main thing this is found in is starch. So starch is found in, again, lots of different things. It can be found in things like potatoes, in vegetables, in rice, in pasta. Another one is something called cellulose. So cellulose is what plants are made from, and we can't actually digest this. So this is fiber. So this goes straight through our digestive system. If you studied science in high school or after high school, you would have heard of something called the mitochondria, and it's usually called the powerhouse of the cell. This is because the mitochondria is very similar to a power station. So in our homes, we use electricity for everything, from turning on the lights to charging our phones to putting on the TV. We use energy for all sorts of things. But that energy has to come from somewhere. It has to be made, and it's made at the power station. So at the power station, they need input, they need raw materials to make this energy. So that can come from renewable, non-renewable sources, whether it's the wind, it's coal, whatever it is, it has to go into the power station. The power station does what it does, it makes energy, and the energy comes out to us and we use it. For us to have energy to do anything, to just be alive, it has to be made in the mitochondria. And the energy we use is something called ATP. Maybe some of you have studied this before, something called the Krebs cycle. This is something that has tortured science students from the beginning of time. It doesn't matter how many times you learn it, it still never seems to stick. So the Krebs cycle is just this crazy chemical reaction that goes on in the mitochondria, and it uses a lot of things from that our own body makes, but there's two things that we have to put into our bodies to make this process happen, to produce ATP, which is our energy. The first thing is oxygen. So really, we breathe just for this process, to get the oxygen that's in the air, to get it into our cell, to get it into our mitochondria. Another thing that we use is glucose. So we use that one unit sugar, that glucose and oxygen, and then a bunch of other chemicals that we produce ourselves. They come together to give us energy. If we don't have enough glucose in our body, it's smart enough to use things like fat. But this is not meant to be the main source of making energy. It's always supposed to be glucose. It doesn't matter whatever type of sugar you take in, whether it's a monosaccharide, a disaccharide, a polysaccharide, or an oligosaccharide, your body has to break it down to glucose because it's not going to use a large chunk of sugar. So because of this, carbohydrates, the saccharides, are divided into two groups. You have the simple sugars and the complex sugars. So the simple sugars are the monosaccharides and the disaccharides. The complex sugars are the oligosaccharides and the polysaccharides. The reason simple sugars are called simple sugars because they're very easy to digest and absorb. When you put it into your system, because it doesn't need to be broken down, it's already broken down into the basic unit. It's easily digested and enters into your bloodstream very quickly, and then it enters into your mitochondria very quickly. It's basically ready to get into the mitochondria and give you energy. So this kind of sugar is good for giving you that instant energy. So people who work out a lot or are physically active a lot, this is the kind of sugar that's good for pumping your energy back up again. That's an advantage of eating this kind of simple sugars. A disadvantage though is because it gets digested and absorbed very quickly, that means it leaves your digestive system very quickly, which means you get hungry a lot sooner. And another disadvantage of simple sugars is because they're quickly absorbed into your bloodstream, it means you're getting a rush of this sugar into your bloodstream, which causes a rapid spike in your blood sugar. And from the last videos, if you have an increase of sugar in your blood, your pancreas produces insulin. So if this is something that happens over a long period of time, that's how diabetes happens. Complex carbohydrates are these chains of these sugar units, and your body can't absorb that. So your body has to break it down into the simple sugars. So this means as it's taking its time to break it down, it's staying in your digestive system a lot longer, meaning you're not going to get hungry that fast because you still have food in your digestive system. Another advantage is because it's breaking it off little by little, that means you're not getting a rush of all this sugar into your digestive system. It's just going in a little bit at a time, meaning your blood sugar doesn't spike up that very fast, meaning your pancreas isn't producing or overworking to produce lots of insulin. And another advantage is that you're having this slow input of sugar into your bloodstream, meaning you're having this slow input of sugar into your cells. That means you're having this constant production of energy. It means you're not getting that hungry, you're staying fuller for longer. It means you're not quickly increasing your blood sugar and making your pancreas produce a lot of insulin. It means you're having this constant supply of energy, so you're not getting that tired. So that's kind of the sciencey part of carbohydrates and what they do in our bodies. So now, how do we know which exact foods have what? When you go shopping and you buy food, if you look at the back, you'll see there's a nutritional label. So there's a part of the nutritional label that has total carbohydrates. So that's whatever sugar it is that's in there is counted in that. than most nutritional labels have, of which are sugars. So this is pertaining to the simple sugars, so the monosaccharides and the disaccharides. So when we're talking about trying to keep control of our blood sugar, this is the part of the label we're supposed to be paying more attention to. So when looking at dietary advice, there's no one blanket answer for everyone, because not all foods affect people the same. You might have two people who eat the same type of food, and it's going to have a different effect on their blood sugar. So it's about wanting to eat something that keeps you fuller for longer, gives you the energy that you need, and it's not increasing things like your blood sugar and also obesity as well. Because with a large increase of things like simple sugars, remember the mitochondria. So the glucose is going in and it's making all the energy, the ATP that you use. So if you're using a lot of energy all the time, then that's good. That means you're using up all that glucose. But what's happening is that people are taking in a lot of simple sugars, but they're not using the energy. They're not physically active. They're not using that energy to do things. So what your body does, it's like, well, since there's no demand for the energy, then we're going to store the glucose, and that ends up being stored as fat. So increased intake of simple sugars is associated with obesity. And last week I talked about the risk factors, and obesity is one of the risk factors for diabetes. So it's advised to focus more on eating complex carbohydrates and trying to decrease the input of simple sugars. There is a place for simple sugars, but we shouldn't be taking it in a large amounts. And eating a balanced diet, so eating carbohydrates in the context of other foods, also helps control our blood sugar. So it's known eating complex carbohydrates also with protein and fats does help control our blood sugar down, because all of these need to be broken down. And remember, the longer it takes for it to be broken down, the more it stays in your digestive system and the fuller you feel. Also exercise, because if you're using all that energy that your body is producing, that means you're not storing up all the extra sugar and all the extra fat as well. But that's it. That's all I have for diabetes. I hope in these 3 videos you've been able to understand some of the science behind diabetes and the science of food. And in the next video, I'm going to be talking about another chronic disease. I've not decided which one yet, but thank you so much for taking your time to watch this, and I'll see you next time. Bye-bye.